So I want to review the slopes, distance, and midpoints here because that will be on the quiz. And we're looking at next week not having any classes because of the scheduling. So I want to make sure we've wrapped that up good. So that slope formula is one that we've seen before. And that was that the slope of an equation, or the slope of a line, if I'm given 2 points on that line, is just y2 minus y1 over x2 minus x1. I guess I really don't need the parentheses there. So if I'm given 2 points, 7, 3, and 2, now let's go 2, 13. To find its slope, I define them as 0.1 and 0.2. Now for the rise, what's going to be y2? 13, good. 0.2, the y-coordinate is 13. And then minus y1? 3, good. 0.1, the y-coordinate is 3. Now that subtracts 13 minus 3 does give us 10. And now for x2 minus x1, x2 is 2, good. 0.2, the x-coordinate is 2. Minus x1 is 7. 0.1, the x-coordinate is the 7. So 2 minus 7 is a negative 5. And we divide it out. 10 divided by negative 5 is negative 2. Now it can be a little trickier if we run into some negative points, like we might have 5, negative 2, and let's do negative 1, 8. So to calculate that slope, I'll label them points 1 and 2 again. What's going to go first here on top? 8, good. y2 is 0.2, y-coordinate is 8. And then, of course, minus, what comes next? Negative 2. y1 is 0.1, y-coordinate is negative 2. Now that does state that is going to be a double negative. 8 minus a negative 2. What is 8 minus a negative 2? 10. Good. On bottom, what's the first number here on bottom? Negative 1. Good. It's x2. That's 0.2, the x-coordinate. Then minus, what's our next point? Our next number? 5. Good. That's x1, so it's 0.1, the x-coordinate. What is negative 1 minus 5? Negative 6. Good. Now to simplify that, to reduce it, first of all, it's a positive divided by a negative. So we know it's a negative. Both 10 and 6 can be divided by what? 2. So 10 divided by 2 is 5. 6 divided by 2 is 3. So that slope is a negative 5/3. For midpoints, the midpoint formula the x-coordinate of the midpoint is found by averaging together the 2 x-coordinates of the endpoints. So you add them together and divide by 2. The y-coordinate of the midpoint, again, you add together the 2 y-coordinates of the endpoints. Divide by 2. You average them together. So if I have the endpoints 7, negative 3, and 1, 13, to find the x-coordinate of my midpoint, what 2 numbers am I going to add together? 7 and 1. It's going to be 7 plus 1 divided by 2. What's 7 plus 1?
8.
8, and 8 divided by 2 is?
4.
4. So the x-coordinate of the midpoint is 4. So what numbers am I going to use for the y-coordinate of the midpoint?
-3, 13.
Perfect. -3 plus 13. That's going to be divided by 2. What's -3 plus 13? 10. And then 10 divided by 2
5.
is 5. So the midpoint is 4, 5. If I give you the endpoints, 3, -8, and 11, 2. So to find our x-coordinate of our midpoint, where do we start?
3 plus 11.
3 plus 11,
Divide by 2.
divide by 2. Good. So 3 plus 11 is
14.
14, and divided by 2?
7.
7. So the x-coordinate of the midpoint is 7. How about for the y-coordinate?
-8 plus 2.
Okay, -8 plus 2, divided by 2. What's -8 plus 2? -6. Good. -6 divided by 2? -3. So the midpoint is 7, -3. Now, if you recall, we also did a couple of examples where we had the midpoint and we're missing one of the endpoints. So remember, we labeled the endpoints points A and B, and the midpoint was point M. So if I tell you that point A is -1, 7, and the midpoint is 4, 4. Now let's make it 4, 3, make it a little interesting. 4, 3. To find point B, if you remember, we put in just x and y as those coordinates, and then we solve for it. If I didn't have the midpoint here, if I were trying to find the midpoint from points A and B, what would I start by adding together? It'd be the -1 would add to x. -1 plus x divided by 2. And that's going to give me the x-coordinate of my midpoint, which we already know is 4. Now I have to solve that to find this x-coordinate. What do I have to do first to solve this equation? The whole side over here is divided by 2, so I'm going to multiply. Perfect, multiply by 2. So -1 plus x equals 4 times 2 is 8. Now what do I need to do to finish solving this? Careful. Yeah, it's a -1, so we're going to add 1. So x equals 9. So 9 is the x-coordinate of that endpoint. For the y-coordinate, we would have the 7 plus y over 2 has to equal what? 3. Good. The y-coordinate of our midpoint. So now our first step here is going to be to do what?
Multiply by 2.
Multiply by 2. So 7 plus y equals 6. And then? Subtract the 7. Good. So y equals 6 minus 7 is? -1. So the y-coordinate is -1. So that other endpoint was 9, -1. to find the distance between 2 points on the graph. If I had points like 2, 7, and I want to know the distance between that point and -3, 19. Our formula to find the distance came from our Pythagorean theorem. It came from that idea of a squared plus b squared equals c squared. But remember, when we did that, we had c squared is equal to a squared plus b squared. We shortened it up by square rooting. So c was equal to a squared plus b squared. And that's exactly what we did here. The distance between those 2 points is the square root of a is found by subtracting the x coordinates. x2 minus x1 squared plus b is the difference in the y coordinates. So 19 minus 7, I'll put it out here generically, y2 minus y1, and then squared. So now let's put these points in there. So again, if I label them points 1 and points 2, what is x2? x2 is -3. Good. Point 2 x coordinate is -3. Minus x1 is 2. Very good. Plus, in the next set of parentheses, y2 will be 19. Good. Point 2 y coordinate is 19. Minus y1 is 7. Good. Point 1, the y coordinate is 7. That's got to be squared. So now we could enter this in the calculator just like that, but I'm going to go ahead and do it by hand. We have -3 minus 2 is careful. -3 minus 2 is -3 plus a -2. It's -5. Plus 19 minus 7 is 12. Perfect. So what is the square? What is -5 squared? Positive 25. Good. Remember, anything squared will be positive. 12 squared? 144. Good. Now our next step is going to be to add them together. 25 plus 144 is 169. I'll give you that one. Now we have to square root it. What is the square root of 169? Is 13. So the distance between those 2 points, 2,7 and -319, is going to be 13 units. If I look on the graph, there's 2,7. -319 isn't going to work for me. There, now we'll make it work. 8, 9, 10. -319 is over here. If I connect those points, what this is all telling me is, if I made this triangle here, the difference of the x coordinates was 5. That's right there. It was -5, but that's 5. The difference of the y coordinates was 12. That's right there. So it's 5 squared plus 12 squared equals that hypotenuse squared. That hypotenuse is going to be the 13. Let's do one more example of finding the distance between 2 points. Let's say I'm going to give you the points -5, 8, and 3, -7. So, this first set of parentheses, what's going to go in here? Three minus -5. Good. Plus my second set of parentheses, what's going to go in there? -7 minus 8. Good. So now -3 minus, or sorry, that's a 3 minus a -5, which becomes 3 plus a +5 is 8. Now -7 minus 8. -15. Good. So now our next step, we're going to square 8. What's 8 squared? Careful. 8 times 8 is 64. Good. -15 squared is going to be the same as 15 squared. What's 15 times 15?
125.
You're close. 225. You had the right idea. So now we have to add those two numbers together. 64 and 225 is 289. Then we can square root it. That distance is 17. Now I'm going to go back up here. Once we had this entered in here, we can use the calculator to do this for us. So all we can do is just put in square root. I do have to do parentheses, 3 minus, make sure I use the negative for 5 and not just another minus. Close my parentheses, x squared, plus my parentheses again, -7 minus 8, close parentheses, and x squared. That should give us 17, and there it is. So that's the distance between points. So that's the stuff that's going to be on our quiz coming up at the end of the hour. So now let's take a peek at our new stuff. So our new stuff that I want to go over here before we have our week off is I want to talk about parallel and perpendicular lines. And we're going to start out with a parallel. You know, we talked about that basic definition of parallel that we always get, which is two lines that never intersect. But that only works in two-dimensional space, on a flat piece of paper, basically. If they're floating out in space, it's not enough to never intersect. Two lines that are parallel are always the same distance apart. So now let's look at what this means in terms of graphing. Let's graph the line y equals 3/4 x minus 2. Where am I going to start graphing that line?
-2.
I'm going to start down here at -2. You are correct. From that starting point, what am I going to do? Up 3 and over 4. Good. So I get a line that goes through those 2 points. If I want to make a line parallel to that, for example, this red line, what do I notice about this line? Well, its y-intercept has changed because I moved the line. But what do we notice about the slope of that line? It stays the same slope, right? What was the slope of this green line? Well, from our equation, the slope is that number that gave us the rise and the run. It's the number that multiplies x. So the slope of that green line was 3 over 4. 3/4. What's the slope of this red line? 3/4. Good, it's the same slope. Parallel lines have the same slope. So if I look at equations, you should be able to tell whether they're parallel. So if I give you the equation y equals negative 1/2 x plus 7. If I give you the equation y equals negative 3 minus 1/2 x, is that parallel to that first equation? Well, maybe we should do this. What's the slope of this equation up here? Negative 1/2. Good. What's the slope of this equation here that I just wrote? Negative 1/2. So are they parallel? Yes, they are. So that line is parallel to it. If I give you 2y equals 8 minus x, are those lines going to be parallel? Well, the way they're written, we can't really tell. Remember, to read the slope out of the equation, we need to solve for y. So what do I have to do here to get y by itself? Right now it's being multiplied by 2. I have to divide by 2. We'll make that y go away. Or we'll make the 2 go away and leave the y alone. When I divide, though, I have to divide every digit on each side by that number. So 8 divided by 2 is 4. I think of this as being a negative 1x. So negative 1x divided by 2 is negative 1 over 2x. What's the slope of that line? Negative 1/2. Is that parallel? Sure is. It has the same slope. So looking at this one, will this equation, will this line have the same slope as our first one? Will it be parallel with our first one? Well, we have to get y by itself. So that means we have to get rid of the negative 6 and the 3x. So remember, I have to go in reverse order. So the first thing I'm getting rid of is the 3x. How do I get rid of it? Careful. I've got to get rid of the whole thing. I'm not just separating the 3 from the x. So I have to subtract 3x, actually. If I was separating the 3 from the x, then I would divide them because they're multiplied. But the whole thing, that whole 3x has been added to the y. So to get rid of it, I subtract the whole thing. So what's left there right now is negative 6y. And on the other side, I have 12 minus 3x, which is just 12 minus 3x. What's next? Well, the negative 6 is doing, how is it attached? What operation attaches it to the y? It's multiplied. So to get rid of it, I need to divide by -6. So the -6 cancels out. I have y here. I have to divide every digit on the other side by -6. What's 12 divided by -6? -2. -3x divided by -6. It's a positive, and negative divided by negative is positive. And I'm just going to put 3 over 6x. And of course, 3 over 6 can reduce to 1/2. Is that parallel to this original equation?
Yes.
What's its slope?
Positive 1/2.
Positive 1/2. What's the slope of this one?
Negative 1/2.
-1/2. So they're not the same. They're similar, but they're not the same. So that equation was not parallel to the original one. So to be parallel, they have to have the exact same slope. Let's look at perpendicular. To be perpendicular, they have to come in at a right angle. Hey, there's Mr. Berghammer. I understand that the stuff I sent Wednesday morning didn't come through for you.
Well, I have a technical math 355, a technical math 165, and a technical math 165. Two of my worksheets, and one of them is a quiz.
Yep, those are the ones. So the first,
You want me to hand those out now?
the first worksheet that says slopes and parabolas on it, that's the one we worked on. We worked on that Wednesday. Then the other two, the quiz and the worksheet that says parallel and perpendicular lines, that one we'll be getting at about 3 o'clock today.
Okay, so I kind of have them all in a packet, so.
Okay, we'll just give it all to them at 3 o'clock. That'll be fine.
Okey dokey.
Thank you.
Thank you.
Okay, so let's look at perpendicular. So we're going to put a line up here. Y equals 1/3 x plus 2. So if I go to graph that, where do I have to start?
Positive 2.
+2, good. And then from there, we're going to go
Up 1 over 3.
up 1 over 3. Good. And that's our line. Now, I'm going to make a line that is perpendicular to it at this point. So perpendicular means it has to form a right angle. Now, I'm going to draw in this slope triangle here. We've got a rise of 1, run of 3. Whatever this angle is here, if I draw in a triangle here, this angle has to be the complement of that one. The purple and the red have to be complements. Have to add to 90 degrees to make that a right angle. Well, if I'm looking at it, if I take this red triangle that I drew in here and I blow it up, not quite that kind of blow up. It's 1/3. So I'll move that down. Oh, we won't worry about it. If I want to make a right angle here, if I want to make an angle that is complementary to this one, well, since this is a right triangle, and I know that the angles of a triangle add up to 180 degrees, I know that that angle plus this one have to add up to 90. Because 180 minus this 90 degrees leaves us with 90 for the other two angles. So what I need is an angle here, this angle here, to be the same as this one down here. So the way I do that is I have to construct a triangle here that's just the opposite. This was up 1 over 3. This has to be up 3 over 1. Now, what I've done there is I've switched the rise and the run. So the rise from one of the slopes has to become the run for the other, And the run from that first slope has to become the rise for the other. In other words, we're doing a reciprocal. Now the next thing we'll see is this first line that I drew. As I went left to right across the graph, it went up. So it has a positive slope. That slope was a positive 3. Or positive 1/3, I should say, not positive 3. The other line I drew, this one here, goes down from left to right. In order to intersect it at a right angle, it has to go down as it goes across the graph. So that has a negative slope. Its slope, and we said we're going to exchange the rise and the run, that slope is a negative 3. So I have slopes of a positive 1/3 and a negative 3 to make perpendicular lines. If I think of this as being a negative 3/1, I can see better that this perpendicular line is first off the reciprocal. As we said, we exchange the rise and the run, or the numerator and denominator, and it's the opposite because I had to make it negative. So perpendicular lines have slopes that are opposite reciprocals. So if I'm going to look at an equation, if I'm going to look at a line, let's say I have y equals 3/4 x plus 2. What is the slope of this line? Let's not throw stuff, guys. The slope of this line is 3/4. Good. What is the slope of its perpendicular?
4/3.
Not just 4/3, but negative 4/3. That's the opposite. So I have y equals negative 2/5 x plus 1. What is the slope of that line? Negative 2/5. Good, just the number that multiplies x. What is the slope of the perpendicular? Careful. This one was negative, so this one's going to have to be positive 5/2. So if one of them's negative, the other one has to be positive. So if I have the equation y equals 3x minus 7, what's the slope of this equation? Just 3. Now to make this simpler on us, we're going to think about that as a 3/1. What's the slope of the perpendicular? Negative 1/3. Perfect.
I should.
Okay, guys, settle down. Okay, put the clipboard back up on the front table. So, let's get back to her. So let's say y equals a negative 2x plus 5. What is the slope of that equation, that line? It's negative 2. So now the slope of the perpendicular, positive if I think of that as being negative 2/1, it's going to be positive 1/2, 1/2. So we can figure out from the equations we can find the slope of the parallel or the perpendicular line. So let's look at now finding equations. If you remember, before spring break, we worked on, if I give you that the slope of a line is 3/4, and that the line goes through the point 6, 3, I can find that equation. I found that equation by starting out with y equals the slope times x. So it's 3/4 times x, and then plus or minus whatever this y-intercept is, b. Then we found b by using this point. For y, we put in the 3. For x, we put in the 6. And we solve for b. So 3/4 times 6 is going to give us 4.5. We subtract the 4.5. 3 minus 4.5 is a negative 1.5 equals b. So what that tells us, one, that I did a very poor example, but it tells us that our original equation was y equals 3/4 x minus 1.5. Look familiar to everybody? Yeah, okay, good. So then what we're going to work on, our next step today with these parallels and perpendiculars, is we're going to work on things like this. If I want to find the equation of a line that is, now we're going to assume this phrase is starting off every problem we're going to do for the next several minutes, so I don't have to rewrite that phrase every time. So find the equation of a line that is parallel to y equals 1/4 x minus 3 and through the point 2, 5. Well, oops, let me make that work a little better. Let's say we're going through the point 8, 5. It'll be easier for us. So the first thing we have to do here is find the slope of this line. What's the slope of that line in the equation? 1/4. Good. The number that multiplies the x. So now we're trying to find the parallel. So the slope of the line that's parallel, is that going to be the same slope or the opposite reciprocal? The same slope. So that'll also have a slope of 1/4. So that means we're going to start off this equation as y equals 1/4 x. And then we got to figure out what that y-intercept is, what b is. And that's where we use this point that it goes through. So y is going to be the 5 equals 1/4 times x will be the 8 plus b. What's our next step? One-fourth times 8. And what does that give us? 2. Good. So 5 equals 2 plus b. Next we have to subtract 2 to get b by itself. So 5 minus 2 is 3 equals b. So b is 3, which means we come back up, actually right here. Y equals 1/4 x plus b. Well, y equals 1/4 x plus 3. If we ask, again, find the equation of the line that is perpendicular to y equals 1/3 x minus 4 and goes through 2, 2, 1. So once again, we need to find the slope of this line. What is that slope? 1/3. Now this time we're finding the perpendicular. What's the slope of the perpendicular? -3/1. Perfect, or just -3. So what that tells us is our equation starts out as y equals -3x plus that y-intercept of b. So then we use the point, put 1 in for y, 2 in for x. What's next? -3 times 2 gives us -6. Good. And finally, careful. It's a -6, so we add 6. Yes, so we get 7 equals b, which tells us y equals -3x plus b becomes y equals -3x plus 7. Okay, it is that time, so take about a 3-minute break, and we'll come back in about 2:48 or so. Okay. So again, let's take a look at, let's find the equation of a line that is parallel to y equals -2/3 x plus 11, and it goes through the point 6, 1. So what's the first thing we need to find? Okay, the slope of this original equation is -2/3. Now we're asked for the parallel. So what does that tell us about the slope of the parallel? Careful. It's parallel. Same thing. Very good. -2/3. So now our equation is going to start out as y equals -2/3 x plus b, right? So then what? What do we put in for y? Oops, careful. 1, there you go. -2/3 times, what goes in for x? That's the 6, good. And find b. Next step. -2/3 times 6. And then -4, very good. And then finally, add 4. So 1 plus 4 is 5. That equals b. So we come up here, the y equals -2/3 x plus b becomes y equals -2/3 x plus 5. That's our equation. So once again, find the equation of the line that is perpendicular to y equals 2x minus 9 and through the point 6, 2. Where do we start? Yeah, we find the slope of the original equation, which is what? 2. Good. Now we're looking for a perpendicular. Its slope will be
1 over 2.
Negative 1 over 2. Good. We think of this as 2 over 1. So the reciprocal is 1 over 2, and the opposite will become negative. So then our equation starts out as y equals perfect. Negative 1/2 x plus b. Then we're going to put in our coordinates 6, 2. What goes in for y? 2 equals negative 1/2 times 6, and then plus b. So then what? Perfect. Negative 1/2 times 6 is negative 3. And then add 3. 3 is negative, so we add 3 to get rid of it. You get 5 equals b. So y equals negative 1/2 x plus b becomes negative 1/2 x plus 5. So again, find the equation of the line that is parallel to two x plus 5y equals 10, and through the point 10, 5. So we have to start with finding the slope of that original equation. Unfortunately, it's not in our slope-intercept form. So 2x plus 5y equals 10. We need to solve it for y to get y by itself. Y has been multiplied by 5, and then 2x has been added to it. So to take it apart, what's the first thing we have to do? Subtract the 2x. Very good. So over here we've got 5y still. 10 minus 2x is 10 minus 2x. Then what? Divide by 5. So y equals, we have to divide each digit by 5. So 10 divided by 5 is 2. Negative 2x divided by 5?
6.
Negative 2 over 5, and then x. So what is the slope of this equation? Negative 2/5. So the slope of this equation is negative 2/5. The parallel will be the same. That'll be negative 2/5. Very good. So that means our equation starts out as y equals negative 2/5 x plus b. What goes in for y? 5, good. Equals negative 2/5 times 10 and plus b. And then perfect. Negative 2/5 times 10 is negative 4. And then add the 4, right? It's negative 4, so we add 4 to get rid of it. So 5 plus 4 is 9 equals b. So y equals negative 2/5 x plus b becomes y equals negative 2/5 x plus 9. So sometimes we're going to have to rearrange the original equation to make it usable to find the slope. So again, find the equation of a line that is perpendicular to (3x plus 4y equals 12. And through 6, 7. So again, we start by finding the slope of this line. But to do that, we're going to have to do some work. 3x plus 4y equals 12. Where do we start? Careful. The 3x has been added to it, so we subtract 3x. Good. So we have 4y over here. 12 minus 3x is just 12 minus 3x. And then divide by 4. So y equals, we got to divide each digit over here by 4. So 12 divided by 4, 3. Negative 3x divided by 4, negative 3 over 4x. So what's the slope of this line here, of this equation? Negative 3/4. So this is negative 3/4. Now we're asked to do a perpendicular. So what's the slope of the perpendicular going to be? Positive 4/3. Good. It was negative, so the opposite is positive. The reciprocal 3/4 is 4/3. So we start our equation as y equals 4/3 x plus b. Good. What's going to go in for y? 7. 4/3 times 6 plus b.
4/3 times 6 is 8.
Perfect. 4/3 times 6 is 8. And then subtract 8. So negative 1 equals b. So we combine that with our original equation here. Y equals 4/3 x minus 1. Okay. So the next thing, the last thing I wanted to show you in this section, and it's kind of an optional topic. What happens when we have things like y equals x squared plus 5x plus 6? If we want to graph that, or solve it even, to graph it, we need to be able to factor it. Factoring is kind of the reverse of the stuff we were doing at the end of last semester, where we would multiply x plus 2 times x plus 3. We did that FOIL process. X times x is x squared. X times 3 is 3x. 2 times x is 2x. 2 times 3 is 6. And that combined, the x squared stayed the same. We combined the 3x and the 2x to make 5x. And then we had the plus 6. Well, you can see I chose that intentionally. That's what I have right here. So this equation here, y equals x squared plus 5x plus 6, is the same as saying y equals x plus 2 times x plus 3. This here is what we call the factorization, or the factoring of this. We've just split it up into two factors. Now, if we were going to graph this, one of the biggest points of interest on a graph is called the zeros, or the roots. The zeros are where y equals 0. So the roots are where y equals 0. So that means I would put 0 in here for y, and I'd be looking at 0 equals x plus 2 times x plus 3. So a very powerful rule in algebra, it's simple but very powerful, is the zero product rule. Anything times 0 is 0, right? You know your face will stick like that, don't you? He's not paying attention. One of the more powerful parts of the zero product rule is, again, anything times 0 is 0, but a more powerful version of it is if two things multiply to make 0, one of them has to be 0. So if x plus 2 times x plus 3 equals 0, either x plus 2 equals 0 or x plus 3 equals 0. So I can solve that by subtracting 2. Here either x equals negative 2, or I solve this one by subtracting 3, or x equals negative 3. So what that is telling me is on my graph, the zeros, the roots, are at x equals negative 2 and x equals negative 3. And from there we would then figure out how to sketch in the rest of our graph. These being squared like this, they're going to form that parabola. Now that, like I said, that is an optional part of this class. So I briefly mentioned it here so you've seen it. It's on your homework worksheet that you're going to get. It's problems 1 through 6. You do not have to do those problems. So 1 through 6 on the worksheet are optional. I'm not going to force you to do them. If you want to try them, that's fine. Go ahead and do it. I'd be happy to discuss it with you next class. But problems on the worksheet, you're going to get problems 7 through 36 do need to be done. So no 1 through 6, but do 7 through 36 on the worksheet. Mr. Berghammer, are you in the room? No, he's not. Did he leave the packets there for you guys somewhere?
No.
Yeah? Okay.
Yeah.
If I grab that packet, in that packet there's going to be 3 things. There's one that's labeled, actually on the top it's labeled Tech Math 165. Technical Math 165 worksheet, slopes and parabolas. That is the worksheet from Wednesday. So that's homework from Wednesday. There's another one in there that should be labeled also Tech Math 165, labeled Quiz 11-1 Graphing Lines. That's the quiz you're going to need to get done right now. And then the final thing that's in there, it's labeled Tech Math 164 Worksheet. It's going to be graphing lines, or quadratics, parallel and perpendicular lines. That is the worksheet that is due for our next class. So for right now, I'm going to have you do that quiz first. So you'll have to pull it out of your packet, obviously, so you can hand it in. But
I don't see the 164.
are there only 2 pages on the packet?
Yeah.
Okay. I just sent him the other one, so he may have to print off the 164 for you. But you do have that quiz 11-1?
Yeah.
Okay. So we'll start off with that for right now.
Yeah, what should, do you want me to go print that off now?
Yeah, if you wouldn't mind, they'll need that to work on for, well, it'll be a week and a half before we meet, but they'll need that to work on for homework. Thank you.